So let's go into the questions. So question number 61. Which of the following sentences related to the Earth is incorrect? The question is demanding the incorrect statement. First one, the speed of rotation of the Earth increases from the equator towards the polar region. Okay, next, the gravitational force and the coldest force are lower near the equator and they are higher near the polar region. Okay, so let's see the explanation. We know that generally Earth rotates from west to east, and the Earth rotation generally decreases from equator towards the poles. It decreases because the Earth rotation speed is directly proportional to the area of the Earth. We know that area of the Earth is higher near the equatorial region. That's why its rotation speed is very high. That is up to 1680 kilometers per hour, and it gradually decreases towards the poles, and where it is 0 kilometers per hour. So in the 45-degree latitude. Okay. So in the 45-degree latitude, it is half of the equator rotational speed. That means nearly 840 km per hour. And near the 80-degree latitude, it is hardly 10 km per hour. And in the polar region, it is 0 km per hour because the landmass of the Earth keeps on decreases towards the polar region. That's why, because of the more rotation speed and because of the centrifugal force, the Earth near the equatorial region got bulged and it is flat near the poles. So this shape of the Earth we call it as the geoid. Okay. So according to the explanation, the speed of rotation of the Earth not increases, it decreases from equator towards the poles. Next one, the gravitational force and the Coriolis force are lower near the equator and they are higher near the polar region. This statement is correct. Let's see. Both gravitational force and the Coriolis force, are greater near the polar region and they are very less near the equatorial region. So what is gravitational force? It is equals to m1 into m2 by r square. Okay. Next, the gravitational force is also related to the nickel and iron content of the Earth. The Earth core region, it is very closer to the polar region. That's why the gravitational force is more near the core region compared to the equator. So then comes the Coriolis force. What is this Coriolis force? It is the imaginary force created due to Earth rotation, as the Earth rotates from west to east. So because of this Earth rotation, an imaginary force is created, because of which objects in the northern hemisphere, they deflect towards the right side, and in the southern hemisphere, they deflect towards the left side. Just imagine, if an object coming from the equator towards the polar region, and it is from either east to west or west to east, in the northern hemisphere, irrespective of its initial direction, it deflects towards its right side. This is how it reflects. Similarly, in the southern hemisphere, irrespective of its initial direction, it always deflects towards its left side. Clear? This is called as the Coriolis force. This Coriolis force, it is more near the polar region and it is very least near the equatorial region. The rate of deflection of an object depends on the speed of the object. If the object is moving at a very greater speed, the deflection will be very higher, and vice versa. Clear? So both this Coriolis force and gravitational force are least near the equator and they are very higher near the polar region. Clear? According to the explanation, the speed of the Earth rotation decreases from equator towards the pole. So first statement is incorrect. The gravitational force and the Coriolis force are lower near the equator and higher near the polar region. So second statement is correct. But the question is demanding the incorrect statement. So only one is incorrect because second statement is correct. Clear? Next, question number 62. Moon is called as the frozen planet because it is very close to Earth. It is a natural satellite to the Earth. It is the remnant of the Earth and all of the Earth. Let's see. So this is the brief history about the Moon's formation. What it says, say around 4.2 billion years ago, the planet's formation took place. Okay. So soon after the formation of the Earth as one of the planet, a minor celestial body called as a Theia, it got collided with the Earth. Because of its collision, some part of the Earth got detached. And because of the internal gravity, they united. And this detached part, it started to rotate around revolve around the earth because of it came under the gravitational influence of the earth. So this celestial body now it is called as the moon. The portion where it got detached, that portion of the earth, it is filled with the trench. The trench is filled with the water body. That huge water body is called as the Pacific Ocean. So Pacific Ocean is the place where the part of the earth got detached. So that's why as it is got detached from the earth, so we call it as the moon as a fossil planet because it is a remnant of the earth itself. Clear? That's why though it is a natural satellite of the earth, it is very close to earth, okay? But the question is remaining fossil planet. The keyword is fossil because it is a remnant of the earth. Clear? So option C is correct. By the way, our official name of the moon is Luna. Moon and satellite are the synonyms, but the actual name is Luna. That's why we call it as a lunar eclipse. Okay. Next question number 63. Which of the following sentences is correct with respect to latitudes? Okay, so more clear information. There are 180 latitudes on the earth, including the equator. Next, these are actually drawn, and these tell us exactly the place on time. Next one, since they join one or the other at the north and south poles, distance between them is not equal. Okay, so let's see. What are latitudes? So generally we know latitudes are the imaginary lines drawn connecting east to west or west to east, which are located at an angular distance from the equator. So this is the equatorial line which divides the earth into two equal halves. And these two halves are called as the hemispheres. Hemi means semi or half. It is called as the northern hemisphere and as the southern hemisphere. So from this we keep the protractor and from 90 up to 90 degrees we draw the latitudes. That's why these are called as the angular distance from the equator. Both in the north and the southern hemisphere, we have the 90 plus 90, and including the equator, it is 181 latitudes. Clear? Okay. These are actually drawn. No, these are not actually drawn. These are not physically present. They are just imaginary lines. Just for our study purpose, we have drawn this. Clear? So, including the equator, it is 181. So, because of the 180, it is also wrong statement. Since they join one another at the north and south, no, they are not joining at the north and south pole. These are parallel lines. They never meet each other. Okay, so that's why third statement is incorrect. The distance between them is always equal. Between each latitude, the distance is nearly 111 kilometer. Clear? So, third statement is incorrect. These are not actually drawn, and even the first statement is also incorrect. So the question is demanding the correct statement. So according to the explanation, none of the statements are correct. All the three are incorrect. Next question number 64. Which of the following motions are example for the micro movements of the earth? Okay. Option A, tilt in the axis, B, eccentricity, C, daily rotation or rotation of the earth, and annual revolution. Okay. So what are these micro and macro movements of the earth? The earth motions can be divided into micro and macro. What are these micro and macro movements? The movements of the earth which we can experience are called as the macro movements. Which we cannot experience, they are called as the micro movements. Best is the tilt in the axis. Tilt in axis. We know that earth is tilted to 23.5 degree from its axis. Even this 23.5 degree tilt is also not constant. It keeps on varying up to plus or 1.5 degree. That means it can come up to 25 degree or it can go up to 22 degree also. But this we cannot experience it. So this is one micro movement. Second one is the eccentricity. What do we mean by eccentricity? We know that the distance between the sun and earth is nearly, on an average it is 150 million kilometers. But it is also not constant. It keeps on varying from 147 to 152 million kilometers. We got to experience this difference. So that's why, but both rotation and revolution we can experience because of the sunrise and sunset we knew that earth is rotating. And because of the revolution around the earth, we can experience and see that we are experiencing the seasons. That's why, according to the explanation, tilt in the axis and the eccentricity, these are example for the micro movements of the earth. Whereas the daily rotation and annual revolution, they come under the macro movements because we are experiencing it. Clear? So, only option E, 1 and 2 are examples. Clear? Question number 65. Which of the following changes can be observed due to daily rotation of the Earth? So tides in the oceans, time difference, Coriolis force, day and night, change in the direction of the winds and ocean currents, and finally the directions. Okay, let's see. We know Earth is rotating almost within 24 hours. Within 24 hours, the Earth rotates on its own axis. So because of this, the sun appeared to be rising in the east and setting in the west. So this is nothing but the directions. So because of the differential heating and cooling of the land and water on the Earth, there will be a local winds and movements of the ocean currents also. And because of the sunrise and sunset, we are experiencing the day and night. And because of the Earth rotation also, there is an imaginary force called Coriolis force. And because of the Earth rotation only, for every 15 longitudes, we are experiencing the 1 hour time difference. Because the sunrise will take exactly 4 minutes to cross the each longitude. 4 minutes to cross each longitude. For 15 longitudes, it will be exactly 60 minutes. That means for every 15 longitudes, we have a 1 hour time difference. Then finally, the tides in the oceans. Because every day, the Earth comes under the gravitational influence of the sun and moon. That's why we are experiencing the diurnal tides. So all of the above. Okay. So all the above changes can be observed due to Earth rotation. Yeah. Question number 66. Which of the following sentences is incorrect with respect to longitudes? Right now we have discussed the latitudes, now it is the longitudes. These are parallel lines that meet east and west. Next, the distance between these is constant, that is 111 km. Next, the international date line is a straight line and makes a difference in the date. Next, the sunrise take 5 minutes to reach the one longitude to the other. The Greenwich prime longitude passes through the London. Let's see the explanation. We know these are the longitudes. The vertical lines connecting from north to south. Just like we know that equator divides the earth into two equal halves horizontally. Similarly, the longitudes, the prime meridian also divides the earth into two equal halves as the eastern hemisphere and the western hemisphere. Just like from the placement line, the equator, we have drawn the 180 longitudes, 180 latitudes in both the hemisphere. Similarly, we have drawn the 360 longitudes in both the hemisphere. 180 longitudes in the east and 180 longitudes in the west. Okay, so totally we have the 360 longitudes. But these longitudes, they are running vertically, connecting north to south pole. That's why when they are connecting north to south pole, because of the earth is in a bowl shape. Okay, as the earth is in the round shape nearly, so all the longitudes will be meeting near the polar regions. That's why the distance between the longitudes will never be same. Clear? The maximum distance between any two longitudes can be seen in the only equatorial region, that is nearly 111 km. And distance between any two latitudes is also 111 km. Clear? The international date line. This is the vertical line which divides the eastern and the western hemisphere and also marks the end of the previous day and beginning of the new day. But it is not a straight line, unlike any other longitudes. It is drawn in a zigzag way in the Pacific Ocean, because here we have the good number of island nations. If a international date line passes through any country, it makes the time and date difference within a single country. So that makes the differences in the administration, or it makes it a bit difficult in the administration because of the time and date confusion. That's why it is drawn in a bit zigzag way. Clear? So according to the explanation, these are not parallel lines because all the longitudes are meeting in the north and south pole. They are not running east to west, they are north to south. So first statement is incorrect. The distance between this is constant. No, it is not constant. The distance between any two longitudes keep on decreasing towards the polar regions. That's why, though it is maximum near only the equatorial region. Okay, so second statement is also incorrect. The international date line is a straight line. Though it is a straight line, but it is not a straight line, it is in a zigzag way. So though it makes the difference in the date, but it is not a straight line. It is a bit drawn in a zigzag way. So third statement is also incorrect. Fourth one, the sunrise, they will not take 5 minutes. They will take exactly 4 minutes to cross the each longitude. That's why for every 15 longitudes, we have the one local time zone. Okay. Next, the Greenwich prime longitude passes through the London. This is the correct explanation. This is the prime meridian which passes through the London. In London, there is a place called Greenwich through which it passes. This is called as the prime meridian. So, because of this is the baseline for to draw the further longitudes. Clear? So, only fifth statement is correct. Rest all are incorrect. But the question is demanding the incorrect statement. So, that means 1, 2, 3 and 4. Except 5, 1, 2, 3 and 4 are incorrect. Clear? Question number 67. The Earth has the elliptical path around the Sun and its total length. We know that Earth is revolving around the Sun in an elliptical orbit. So, what is the orbital length? Option A says 927 million kilometer. Option B says 567 million kilometer. C 347 million kilometer. And D 443 million kilometer. So, let's see. So, this is the orbital path of the Earth around the Sun. So, it is not a straight, it is an elliptical orbit. We know that the distance between the Earth and Sun is not constant. Though average it is 150, so it varies from 147 to 152 million kilometers. That means sometimes it is very closer to the Earth, and sometimes the Earth is closer to the Sun, and bit it is far away. So, with the closeness is called as the perihelion, and the farthest situation is called as the aphelion. The orbital path, the total length is 927 million kilometers. Okay, 927 million kilometers. These are the factual questions. You have to remember this much. Next question. Who invented the days of equinox? You know what is equinox? It is the duration on the Earth where the day and nights are equal. 12 hours of day length and 12 hours of night length. Clear? So, Ptolemy, the Alexander van Humboldt, C. Hipparchus and D. So, it is the Greek philosopher, geographer Hipparchus who discovered the concept of the equinoxes. On this day, on March 22nd, 21st and even September 21st or 22nd. On these days, the sun rays fall vertically on the equator. So, because of which the whole Earth experiences 12 hours of day length and 12 hours of night length, which we call it as the equinox. Clear? So, it is option A, Hipparchus. Sorry, C, Hipparchus. Question number 69. Which of the following sentences are correct? If we cross the international date line from the eastern hemisphere to the western hemisphere, we lose a day. From the east to west, it is saying. Next, time and day are always ahead. Whereas the sun rises first in the eastern hemisphere. Next, if we cross the 15 longitudes from the certain longitude facing north pole and move towards our right, the time will go to 2 hours ahead. So, let's see. This is the globe, and we know that this is the prime meridian, this is the international date line. So, this one is called as the eastern hemisphere and the opposite one is called as the western hemisphere. We know that sun rises in the east because the earth rotates from west to east. Sun rises in the east and sets in the west. As the sun rises in the east, certainly the sun rays will cross the longitudes in the eastern hemisphere first. So, time and date will be ahead in the eastern hemisphere and it is a bit slower in the western hemisphere. Okay. So, just imagine this is the international date line. So, this is the eastern hemisphere. This is the western hemisphere. From the prime meridian, this appears as the eastern and this one as the western hemisphere. If you observe from the international date line, this one is the western and this is the eastern hemisphere. We know that sun rises in the east. That means the time and date will be ahead in the eastern hemisphere. Just if it is Monday, what will be the day in the western hemisphere? It is previous day. Okay, so it will be Sunday. So that means if we cross the international date line from the east and go towards the west, we are in the Monday, but we are going to the previous day, Sunday. After completion of the Sunday, we will get the one more Monday. That means we will gain a day once we go to the western hemisphere. And the vice versa, if we go towards the eastern hemisphere after crossing the international date line, so we are in the Sunday and we are moving towards the eastern hemisphere. There it is Monday. That means before completion of the Sunday only we are going to the Monday. That means we are going to lose Monday and we are going to lose Sunday and going to the Monday. We are putting the calendar one day ahead. That means we are going to lose a day once we go to the eastern hemisphere. Clear? And if you cross the 15 longitudes from certain longitude facing North Pole and move to our right side, time will go not 2 hours ahead, it is 1 hour ahead. Because the sunrise will take exactly 4 minutes to cross the each longitude. To cross the 15 longitudes, it will take exactly 1 hour. That means only 1 hour difference will be there. Clear? So according to the explanation, if you cross the international dateline from the eastern hemisphere and go to the western hemisphere, we will not lose a day, we will gain a day. Because from the east, we are going to the west. If it is Monday here, we are going to Sunday. That means after enjoying the Monday, we are again coming back to Sunday. We will get one more Monday here. That means we will gain a day. But here it is saying lose a day. That's why first statement is incorrect. Second one, time and days are always ahead there as the sun rises first in the eastern hemisphere. So this is correct statement. Next, if you cross the 15 longitudes, time difference will be 1 hour but not 2 hours. So correct statement is only 2. Okay, so option A, 2 only is correct. Clear? Question number 17. On which of the following days the sunrise are vertically on the equator? Again, repetition of the previous concept, equinoxes. So March 21st, June 21st, September 21st and December 21st. Okay, so let's see the explanation. See, this is called as the equinox, where the sunrise falls vertically on the equator. So it is September 21st and the March 21st. Okay, so March 21st and the September 21st. So option C, 1 and 3, which are called as the equinox days. So June 21st is called as the summer solstice. December 21st is called as the winter solstice in the northern hemisphere, and vice versa, it is called as opposite as the in the southern hemisphere. Clear? Because the seasons are opposite in the both the hemisphere.